All right, so going into chapter 2 now, set notations. We'll do a couple of these homework problems as well. Um, so with this one, we have set A, and we have the uniform set U, which is all the letters in the alphabet, and it wants us to find the complement of A, or A naught. So this is basically everything that's not in A. So we put in a curly bracket, and now we go through and list all the letters that are not in A. Notice A's not in order, so you got to be careful with that because it does have an A in it. Does not have a B. It has a C, but not a D. No E. Oops, move my mouse so I can see. No F. Has a G. No H. It has an I. No J. No K. No L. It has an M and an N, so no O. No P. No Q. No R. Has an S. Has a T. So no U. No V. No W. No X. It has a Y. And then finally, no Z. So uniform set, we have set A, and we've just found the complement of A. Cardinal numbers, how many are in the set? So we just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9 things in the set. So there is 9 in there. So cardinal numbers, the key with cardinal number is how many are in the set. All right, so that U consists of a set of animals. So they've created the Venn diagrams, and they want you to tell which one is mammals and rabbits. So mammals, it looks like it is a black circle, and rabbits are red, right? So when the circle is completely inside the other circle, that means that all of that counts. So if the red circle is on the outside, you have your rabbits, and you have your mammals. So every mammal is a rabbit, is what the first Venn diagram says. The second one there's some mammals and there's some rabbits, and then there is an overlap. Right, so for this one to be correct, there would have to be rabbits that are not mammals. So that one's out. This one is what we call disjoint or mutually exclusive. They do not connect. So they have nothing in common. Well, rabbits are mammals, so they should touch. And then finally, our last one, we have all mammals. And in the group mammals, there is a subset of rabbits. So the fourth Venn diagram is the correct answer. Remember our symbols. Again, if you don't remember them, we can always go to the OneNote, and then I have the table, right? Somewhere in here I have a table. No, that's in my next set. So we got to remember our ands and our ors. There's our complements. Thought I had a table with these in there. Let's go to chapter 3. It might be in 3.1, which we're going to start this week. There it is. So, because chapter 3 is very similar to chapter 2, or 3.1 is at least. So when it's an upside down U, that is and. When it is looks like a capital U, that is or. And then our lovely friend, the not. So and or. So I'll go back to my review. It wants us to find, I'll bring up my pen, and this is what you can do to make it easier on you as well. You can just put the words. So this is and this one is or. So just like before, we do order of operations. So we have to have Q or R. So that means that can be any one of those numbers. And then and P. So what it needs to do is what letters are in P and in Q or R, right? So basically, what do these three things have in common? So I have an S, so I see an A and an A. I see an M and an M. I see no P's. I see an L and an L and an E. So it looks like the only thing they have in common is ALME. And again, you can go in any order just like they did. So get my pen here for a minute. Bring into my lovely curly brackets. So I have an A, L, M, and an E. All right, because or means I could be in either one. That's why I dropped this box. So alls are all of those value or letters, sorry, in that set. And then a P is up here. So then I had to look and see what did they have in both. And means they must apply in both. All right, so for this one, cardinal numbers, we got to walk through the set notation and decipher everything that it is saying. So Z is the symbol for integer. So this is an integer, which means like our positive and negative numbers, natural numbers. So -5, 0, +3, right? T is odd. So let's list all of those out right now. And I'll do it in a text box, so it's a little easier to see. And so we can, and I can see that I have to be less than or equal to 7. So I'm going to go -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and 7. All right, so this isn't the answer. I'm just listing out the numbers, and then we're going to start taking out the ones that don't count. So it says T is odd, right? So therefore, we can take out all the numbers that are not odd. So -6 is not odd, -4 is out, -2, 0 is neither even or odd, 2 is out, 4 is out, and 6 is out. So I'm left for those, and they're integers, and they're less than 7. And the reason I stopped at -7 is because of the absolute value. Remember, absolute value is how far you are from 0. So the absolute value of -7 is equal to 0. I'm sorry, is equal to 7. Gosh, how far you are from 0, not equal to 0. And I am 7 steps to the left. So therefore, that is I am 7 away. Right, so it doesn't say it takes it out. It's just saying if that number makes it true. And so -7 does make that true because it's less than or equal to 7. So therefore it counts. Cardinal numbers, how many are in the set? So I start counting. I got 1, 2, 3, 4, 5, 6, 7, 8 answers. So our answer should be 8. And it is. All right, so break it apart in pieces and then start taking out what does not count. All right, so let's see another one. Here is our Venn diagram. So this one's already built for us. It's just asking you to pull numbers out of that one. So the following vendor, how many movers have traveled to Germany, France, and Spain? How many students have been to none of these countries? What it's asking. So that's outside the circle, which is the number 5 out here by right under the U, because that's outside the circles. So 5. Remember, the absolute values things mean cardinal numbers. So D or E. So how many things are in D or E without double counting? So you can see they both have a P, they both have an N, they both have a T, they both have an I. So A and R is the only difference. So there's 1, 2, 3, 4, 5, 6 numbers in there. So it doesn't say cardinal this time. So remember, the absolute value symbols when you're in set notation means how many elements, or means you count up everything that's in both, but do not double count. All right, so this one we're going to fill in the Venn diagram used on the cardinal numbers. So A has a total of 31. So that is all the numbers in A, all of them, right? So everything in A. So you can't put 31 in the first box because A has 4 different boxes in it. So just like we said before, we start with, well, we can start with easy to U. There's 92. So this one is going to be, actually, I'll just get rid of my thing and just type that one in there because that one's the easy one, 92. A and B and C, that is where I get the triangle that's in all 3. That would be this triangle right here that's in all 3 circles. So that's where I put my A, B, and C numbers. That's 16. Now I can work my way out. So B and C, just to make this a little bit neater, I'll get rid of that triangle. So where is B and C? So B and C, sorry, trying to bring my pen here at the same time. B and C is this guy right there that I'm circling. So if there's 19 in B and C and there's 16 that numbers already in there, that means this one has to be 3 because 16 plus 3 is 19. That number's done. Now A and C. So this is A and this is goes into C. And I know B's in part of it, but it's not saying B's not in part of it. We're just looking for words in A and C, which is that circle. Oh, no, it's not. Sorry. That's not it. A and C is this circle right there. There we go. I had A and B circled before. That's A and C right there. Because A and C, so 16, and I have to get to 25. So that means that missing number is 9. And then finally, B and C is 17. 16's in there, so there it goes, my 1. So now C has 40. So you can see I have 3 of the 4 boxes filled. So I just take 40 and subtract out those numbers. So I'll get my trusty calculator. I do 40 minus 3 minus 16 minus 9 gives me 12. And then B has 36. So 36 minus 3 minus 16 minus 1 equals 16. And finally, A has 31. So 31 minus 1 minus 9 minus 16. And I put all the numbers in so you could hear me say them, but obviously you can combine numbers when you solve this problem. Oh, I missed one. No, no explain error. Try it again. So we all make mistakes, so now I see it. So what my mistake was this 92. Remember, 92 is all the numbers added together. So when I put 92 in here, I double counted. So we got to remove the 92. We need to take 92 and then subtract all of these numbers to figure out how many are not in the circles. I double counted. So that's why I said be really careful when we put these numbers. U is all the numbers in the box. So they all have to add up to 92, not put 92 on the outside like I just did. So 92 minus, I'm going to minus all the numbers in the circles instead of doing tricks right now because everybody's learning. So minus 5, minus 9, minus 1, minus 16, minus 16, minus 3, minus 12, which gives me 30. So this 30 of the numbers are not inside the circles. There we go. There we go. Yes, I made a mistake in the video, but that's good because it reminds us again, be careful. U is the total. All of those numbers add up to 92. That is not the number that goes in the box by itself. All right, I think we've done those a few times, so I'll let you work on those. This is a good one. So this Venn diagram is incomplete, and you have a question and answer, right? So we got to complete it. So let's see what numbers are missing. So now, like we have to do almost what I just did a minute ago, we have to decide what is missing here. So 4 have been to all 3 countries. So that's that number right there. Good. 5 have only been to only Spain and France. So Spain and France. Oh, right here at the bottom, Spain and France, only those are the 5 that have only been to both. Now, if the word only is why it goes out there. If it was Spain and France, it would be the full circle like we just did a minute ago. But because it's only, then it's just a little piece of number out here. 6 have only been to France, so that's that number, okay. 5 have only been to Germany, that's that number right there. 11 have been to Germany and France, that's the 7 plus 4, because it doesn't say only, so that means that does include Spain. So that's where the 11 is, the 7 and the 4. 22 have visited France, that should be all these numbers added together. 11 plus 11 is 22. 19 have been to Spain. So you can see we have 9 and 11 already in the box. So 11 total, 5 plus 4 plus 2. But there's 19. So that means 8 goes out here where this question mark is. And then 18 to visit Germany, so that is good as well. They don't give us enough information to figure out what U is. Oh, yes, they do right there, 43. Helps if we all read. So 43, so if I take all the numbers, 43 minus all those numbers, I again will find the number on the outside. So 43 minus 7 minus 5 minus 2 minus 4 minus 8 minus 5 minus 6 equals 6. So there are 6 that haven't been to any of the countries. And finally, we can answer the question, how many students have been only to Spain? Well, we didn't even need the 6. We just needed the lovely friend, the 8. So I can get rid of my pen, come down here and put in an 8. That is a good problem for you to review because I'm pretty confident you'll see that problem again. All right, what else? So another one of those. Definition problem. So writing this out into roster method. So what roster method is just listing out the numbers. So we want, let's go through our set here. We want is a multiple of 3 between the numbers 16 and 32. So I'll do again text where it's a little bit neater. So I'll do it on the outside. So we're gonna list all the numbers, all the integers between 16 and 32. 16, 17, 18, 19, 20. And there's lots of ways to do this problem, but I'm gonna go through this way. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there's numbers between 16 and 32. Okay. Now for something to be divisible by 3, if I add up the numbers, then the sum is also divisible by 3. So 1 plus 6 is 7. 7 is not divisible by 3, so 16 is not divisible by 3. So that's, oops. So that is not one of my answers. So 16 is out. 17 is a prime number, so he's out. 18, 1 plus 8 is 9, and then 9 divided by 3 is 3. So therefore, 18 is good. 19 is a prime number, so that is out. 2 plus 0 is 2, so 3 doesn't go to 20. 7 and 3 is 21, so that one's good. 3 does not go into 22. 23 is a prime number. 3 goes into 24, doesn't go into 25. 26 does not, 2 goes into 27, doesn't go into 28. 29 is a prime number, goes into 30, 31, 32. So I've crossed out all the numbers it cannot be. So now I just put this in curly brackets and I write out my numbers. So what we said? We said 18, 21, 24, 27, 30, and that should be it. So next, clear my notes. Get rid of my pen. Definition, definition, definitions. And we've talked this one and another Germany problem. So there's some good ones. I didn't go through the definitions because you can kind of look through the book and pull the definitions or my notes. So there's the first 2 videos. I'll get these uploaded to our course page. And so you can watch them at your convenience. Have a good day.